Welcome back. Today, we're diving straight into the heart of the smart factory. We're going to talk about how its brain communicates with its body and why getting that communication right is literally a multi-million-dollar decision.
Okay, so before we go any further, let's make sure we're all on the same page. What exactly is an MES? Well, think of it as the factory's brain. It's that central computer system that's monitoring and controlling the whole manufacturing process on the factory floor. It is the brain of the smart factory.
So here's how we're going to tackle this. First, we'll look at the MES's role as the brain. Then we'll compare the two main ways it can communicate, event versus state. We'll look at the ideal way, and then the, let's say, more common reality. And finally, we'll get to the massive choice that every smart factory has to make.
All right, Section 1, the factory's brain. So if the MES really is the brain, the big question is, how does it talk to all the machines? We're not talking about a few. We're talking hundreds, maybe thousands of them on the factory floor. This is the absolute core challenge.
Now, what's really fascinating is the way experts recommend you structure this. It's based on a standard called ISA 95. You see, the MES, that's the brain up at level 3. It doesn't talk directly to the equipment, the body, down at level 1. Instead, it goes through this middle layer, level 2. You can think of this as the factory's nervous system. It's like a translator, and it is absolutely essential to stop everything from descending into chaos.
So why bother with this middle layer? Well, because connecting the brain directly to every single piece of equipment would be a total nightmare to maintain. I mean, think about it. You've got machines on the floor speaking all sorts of different languages. OPC UA, Modbus, the list goes on. If you connect them all directly and then make one tiny change to one machine's program, you could literally shut down the whole system. It's just way too inflexible, way too fragile.
And this brings us to the really crucial point. This nervous system, this middle layer, it can have two very, very different kinds of conversations with the machines, event versus state. Let's break down what that actually means.
And this comparison right here really shows you the core difference. The modern way, event-driven, is basically like a push notification. The machine actively sends a message when something important happens. It tells you. The old way, state-driven, is like constantly hitting the refresh button on a web page. The system has to ask over and over and over again, what's your status now? What about now? Are you done yet?
Okay, so let's take a closer look at the ideal scenario, right? The event-driven method, the push notification method. This is really what modern smart factories are built on.
So the process here is just so clean and efficient. The machine itself, and let's be honest, it's the real expert on its own status, it takes the initiative. It actively sends a process start signal. The middle layer, the IIoT server, immediately relays that message, and the MES, the brain, just logs the start time. It didn't even have to ask. The exact same super efficient flow happens when the job is finished. All the main system has to do is listen.
And this is the key takeaway, really. This whole approach respects the fact that the machine is the expert on its own status. It is the single source of truth. It absolutely should be the one to report any changes. It doesn't need a babysitter constantly checking in on it.
But what about older factories? The reality is that many of them are stuck with this much less efficient method, state polling. This is our constant refresh method we talked about.
I mean, just look at the difference in this flow. The main system is just sitting there waiting for information. So that middle server has to constantly pull the machine's PLC, its little onboard computer, asking, hey, what's your status? Then an operator presses start. A tiny little status bit, maybe it's called Y1, changes from a 0 to a 1. But the server doesn't know that yet. It has to keep polling and polling and polling until it finally detects that change. Only then can it tell the brain, hey, I think the process started. It's so much work.
This approach also creates a massive risk. The system has to rely on this really complex mapping table just to understand what all these little signals mean. So if the PLC program on the machine gets modified and the mapping table doesn't, you will absolutely start capturing the wrong data, and you might not even realize it for a while.
And for the oldest machines, sometimes it gets even more basic than that. Sometimes the only way you can possibly pull the status is by reading the three-color tower light. You know the one. Green for run, yellow for idle, red for down. That's it. That's your data. So, we've laid out these two very different paths. This brings us to the big choice for any smart factory. Why are events so clearly the future?
While the benefits are just overwhelming. With an event-driven system, you reduce the burden on your central host. It's doing way less work. You lower the error rate because there are no fragile mapping tables to break. You get more timely data. I mean, it's instant, not delayed. Your whole system is more stable because everything is more independent. And the messages are just crystal clear. You get a process start message, not some cryptic thing like Y1 is on.
And you have to think about scale. That polling method, it creates a massive, massive burden when you try to scale it up to hundreds or even thousands of machines. It just doesn't work. The load on your system becomes unbearable.
And this, right here, is probably the most important takeaway. If you're building a new factory, specifying event-driven communication is one of the single most important decisions you'll make before you buy any equipment. You have to get IT and operations in the same room to make this a non-negotiable requirement.
So we'll leave you with this one question. Is your factory communicating with push notifications? Or is it constantly asking, are we there yet? Think about it. The difference is absolutely everything.